Hello, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Forces in Our Environment. This is a student reader in Unit 6. Balancing Forces. Walking across a tightrope. Nick Wallenda loves walking on a tightrope. He first walked across a tightrope when he was 2 years old. He had to hold onto his parents' hands. He began walking across tightropes as a job when he was 13. He was the first person to walk a tightrope across Niagara Falls in 2012. 1 year later, he walked across a gorge near the Grand Canyon. He walks on a 5.1 centimeter or 2-inch thick steel cable. Different forces act on Nick as he walks across the tightrope. The force of gravity always pulls down on him. In response, the steel cable pushes back up. It pushes with an equal but opposite force. When this happens, the forces acting on Nick are balanced. The force of gravity pulls down. The force of the wire pushes up with equal and opposite force. Tension on a tightrope. Before Nick begins any tightrope walk, he thinks about where to attach his cable. The cable needs to attach to something on either end to hold it up in the air. The cable needs to be pulled as tightly as it can be. This is to increase the tension on the cable. Tension happens when forces pull the ends of an object in opposite directions. Tension makes objects longer. It is easier for Nick to walk across when the cable has a lot of tension. This is because it doesn't sag very much. Sometimes, the cable cannot be pulled as tightly across as Nick would like. When this happens, the cable will sag a lot in the middle. Nick trains so that he knows how to move on both kinds of cable. Tension is a pulling force that stretches objects. Forces act on structure. People don't realize how much engineering and science goes into everything, Nick said. This is true for all structures. A structure is anything that is made of parts and can support and withstand all of the forces that act on it. As gravity pulls down on structures and the ground pushes back up, it compresses the structure. Compression happens when forces push the ends of an object toward each other. This makes objects become shorter. Some materials compress easily. Other materials are harder to compress. A material is any kind of matter that makes up an object. For example, the cable that Nick uses doesn't compress too much beneath his weight. Compression pushes an object together. The 3 other forces that act on all structures are bending, shear, and torsion. Bending happens when forces cause tension to happen on one side of an object or material and compression to happen on the other side. Shear describes what happens when forces push one part of a structure one way and another part the opposite way. Finally, torsion happens when forces cause an object to twist. Forces act on materials in different ways. Bending, shear, torsion. Withstanding forces. When engineers design a structure, they make it so that it balances all of the forces that act on it. Think of a bookshelf. The bookshelf has to support its own weight. Gravity pulls down on the bookshelf. The ground pushes back with an equal and opposite force. The bookshelf needs to be built with materials that are strong enough to withstand these forces. The bookshelf also has to support the weight of books on its shelves. Too much weight on a shelf will cause the shelf to bend. The top part of the shelf will compress. This will cause tension on the bottom part. If enough weight is placed on it, the shelf will break. It could not balance all of the forces acting on it. Forces and shapes. The shape of a structure also affects how strong it is. This is because of how forces act on each kind of shape. Let's begin with squares. Squares can be strong. Many tables and buildings have a square shape. Squares can be strong when forces push straight down on them. However, think about what would happen if a strong force pushed sideways. A square cannot hold its shape. Triangles can be stronger than squares. This is because any force spreads out across all three sides. This is why engineers add beams to squares to create triangles. Engineering skyscrapers, building up in New York City. New York City is famous for its skyline. The skyline is made up of all of the buildings in an area. New York City has more than 100 buildings that are 183 meters or 600 feet or taller. The tallest building in New York is One World Trade Center. This building rises 541 meters or 1,776 feet into the air. It is a skyscraper. Skyscrapers are tall buildings with many stories that can contain many people in a vertical space. This is New York City's skyline. The weight of the skyscraper. Before engineers build a skyscraper, they have to do research. They need to know what forces will act on it. The skyscraper will have to be strong enough to withstand all of those forces. Many challenges face engineers who design skyscrapers. First, every floor pushes down on the walls and the floors below. People in a skyscraper add more weight to it. As this weight pushes down, the ground pushes back. This causes compression. As materials compress, they can also bend. The skyscraper has to be very strong so it can withstand all of these forces. Engineers use steel beams to resist these forces. Steel is a strong material. It won't crack or break in response to strong compression or tension. The structure of a skyscraper. The first part of the skyscraper to be built is its foundation. The foundation connects skyscrapers and other buildings to the ground. The foundation supports the weight of the structure. A skyscraper needs a deep foundation because it is so heavy. In a regular house, the foundation is less deep. This is because it has less weight pushing down. Many skyscrapers also have a central core. This is the stiff backbone on the skyscraper. It is the central vertical beam that holds the skyscraper in place. The central core is often made of concrete and steel. It supports most of the skyscraper's weight. Concrete and steel don't change their shape easily when forces act on them. Skyscrapers need deeper foundations. Withstanding the force of wind. The central core has another function. It helps to support the skyscraper from the force of the wind. Wind is a major concern in skyscrapers. Remember that wind is air molecules in motion. It has kinetic energy. As wind blows, it applies a pushing force against the structures in its path. Wind causes skyscrapers to bend. Wind sometimes blows harder on the top floors than on the lower floors. This can cause both shear and torsion forces. The side of the skyscraper in the wind will experience tension. The other side will experience compression. Engineers also use supports around the central core. Supports are the beams that run up and down. They can only go diagonally to make triangles. Supports make up the metal skeleton of the skyscraper. So here, this image is showing the foundation. These are the different floors. The central core is in the middle. These are the cross supports, and then the vertical supports. Skyscrapers solve problems. Skyscrapers are common in cities around the world. This is because skyscrapers solve an important problem. As people move to cities looking for jobs, there isn't as much room for buildings. One solution was to build upwards. Skyscrapers need less land. They also allow many people to work and live in them. The Burj Khalifa is the tallest building in the world. I learned a lot reading Forces in Our Environment, and I had fun too. I hope that you learned a lot and that you had fun also. I'll see you tomorrow with another one. Bye.